Imagine a time when there were no oceans, no mountains, no trees, and no humans. Picture a universe where Earth didn't even exist yet. We're traveling back 4.6 billion years to an era when our solar system was nothing but a swirling cloud of dust and gas, drifting silently through the vastness of space. How did this chaotic cloud transform into the beautiful blue planet we call home today? In this documentary, we'll uncover the incredible story of Earth's birth, tracing its origins from cosmic dust to the vibrant world we know now. Truly understand how Earth began, we need to journey even further back in time, about 13.8 billion years ago. This is when the universe itself was born in a moment known as the Big Bang. In less than a second, space-time, energy, and matter all came into existence. The universe expanded rapidly, growing and cooling as it did. This was the very first chapter in the story of everything, setting the stage for the formation of stars, galaxies, and eventually, planets like our own. Billions of years after the Big Bang, gravity began to pull together clouds of hydrogen and helium. These clouds grew denser and hotter until finally the first stars ignited. Inside these stars, nuclear fusion began to create heavier elements: carbon, oxygen, silicon, and iron. These elements would become the building blocks for everything we know, including our planet. The birth of the first stars was a crucial step in the cosmic chain that would eventually lead to Earth. Massive stars reached the end of their lives. They exploded in spectacular events called supernovae. These explosions scattered the elements forged inside stars across the universe. The atoms in your body, the rocks beneath your feet, and the water in Earth's oceans were all created in these ancient stellar explosions. In a very real sense, we are made of stardust. Our planet and everything on it owes its existence to the life and death of stars. Fast forward to about 4.6 billion years ago. In a quiet corner of the Milky Way galaxy, a giant cloud of gas and dust known as the Solar Nebula floated through space. This nebula was rich with the elements created by earlier generations of stars. Something, perhaps a nearby supernova, sent shockwaves through the cloud, causing it to collapse under its own gravity. This collapse was the first step toward the birth of our solar system. As the solar nebula collapsed, it began to spin faster and faster, much like a figure skater pulling in their arms. The spinning cloud flattened into a giant disk with most of the material gathering at the center. This process set the stage for the formation of the sun and the planets. The forces at work here, gravity, motion, and heat, were shaping the destiny of our solar system. At the center of the spinning disk, pressure and temperature increased dramatically. Eventually, the temperatures reached millions of degrees and nuclear fusion ignited. The sun was born, a new star shining in the Milky Way. But this was only the beginning. Around the young sun, billions of particles continued to orbit, setting the stage for the next chapter in the story of Earth's creation. Surrounding the newborn sun was a vast disk of dust and gas. Within this disk, countless particles collided and stuck together, forming larger and larger clumps. These clumps would become the seeds of planets, moons, and other bodies in the solar system. The process was chaotic, with collisions, mergers, and sometimes violent impacts shaping the early solar system. As time passed, some of the dust and gas in the disk began to stick together, forming small bodies called planetesimals. These objects, ranging from a few kilometers to hundreds of kilometers across, were the building blocks of planets. Through countless collisions and mergers, planetesimals grew larger, eventually forming protoplanets, the precursors to the planets we know today. Early solar system was a violent place. Planetesimals and protoplanets crashed into each other, sometimes shattering, sometimes merging. These collisions released enormous amounts of energy, melting and reshaping the young worlds. Over millions of years, the chaos gradually gave way to order, as the largest bodies cleared their orbits and began to dominate their regions of space. Among the many protoplanets forming in the disk, one began to grow larger than the rest. This was the early Earth. Through a series of massive impacts and mergers, Earth accumulated more and more material. Each collision added heat, melting the planet's surface and creating a molten world. The process of accretion, gathering material through gravity, was shaping our planet from the inside out. One of the most dramatic events in Earth's early history was the giant impact. Scientists believe a Mars-sized body called Theia collided with the young Earth. The impact was so powerful that it melted much of Earth's surface and blasted debris into orbit. Over time, this debris came together to form the Moon. The giant impact not only created our Moon but also helped shape Earth's tilt and rotation. After the giant impact, Earth's surface was a seething ocean of molten rock. Temperatures were incredibly high and the planet glowed with heat. Over time, the surface began to cool and solidify, forming a thin crust. Volcanic activity was intense, releasing gases that would eventually form Earth's early atmosphere. The planet was still hostile, but the foundations for a stable world were being laid. Earth's first atmosphere was very different from the air we breathe today. It was made mostly of hydrogen and helium, but these light gases quickly escaped into space. Volcanic eruptions released heavier gases, carbon dioxide, water vapor, and nitrogen, which began to build up a new atmosphere. This thick, toxic air would eventually set the stage for the next big transformation, the arrival of water. But where did Earth's water come from? Scientists think that icy comets and asteroids bombarded the young planet, delivering water and other volatile compounds. Over millions of years, these impacts filled Earth's basins with water, creating the first oceans. Water would become essential for life, but at this point, Earth was still a barren, lifeless world. As water accumulated on Earth's surface, the first oceans began to form. These vast bodies of water covered much of the planet, helping to regulate temperatures and create a more stable environment. The oceans also played a key role in shaping the atmosphere as water vapor condensed and rained down, further cooling the planet. The stage was set for the next chapter in Earth's story, the emergence of continents. With a solid crust and vast oceans, Earth began to develop continents. Volcanic activity and the movement of tectonic plates pushed up landmasses, creating the first continents. Over millions of years, these continents drifted, collided, and broke apart, shaping the surface of our planet. The process of plate tectonics would continue to reshape Earth for billions of years to come. As Earth's surface cooled, the planet became more stable. The crust thickened, volcanic activity slowed, and the atmosphere began to change. Over time, the planet's interior continued to release heat, driving the movement of tectonic plates and fueling volcanic eruptions. These processes would help recycle materials and maintain the conditions needed for life. With volcanic gases and water vapor filling the air, Earth's atmosphere continued to evolve. Over millions of years, chemical reactions in the cooling surface transformed the atmosphere, making it less toxic. Eventually, the stage was set for the most dramatic change of all, the arrival of life, which would transform the planet forever. Somewhere in Earth's early oceans, simple life forms began to appear. These were tiny, single-celled organisms, bacteria and archaea, that could survive in harsh conditions. They fed on chemicals in the water and began to change the atmosphere by releasing oxygen as a waste product. This was the beginning of a long journey toward the complex life we see today. As early life forms released oxygen, the atmosphere began to change dramatically. Oxygen built up over millions of years, eventually reaching levels that could support more complex life. This transformation, known as the Great Oxygenation Event, was a turning point in Earth's history. It paved the way for the evolution of plants, animals, and eventually humans. As time went on, the continents continued to drift across the planet's surface. Plate tectonics caused continents to collide, split apart, and rearrange, creating mountains, valleys, and ocean basins. These movements shaped Earth's geography and influenced the evolution of life by creating new environments and isolating species. Earth's climate has changed dramatically over its history. Shifts in the planet's orbit, the arrangement of continents, and the composition of the atmosphere have all played a role. At times, Earth has been covered in ice from pole to pole, while at other times it has been much warmer. These changes have had a profound impact on the evolution of life. With more oxygen in the atmosphere and stable climates, complex life forms began to evolve. Multicellular organisms appeared in the oceans, followed by the first animals and plants. Over hundreds of millions of years, life diversified and spread to every corner of the planet, creating the rich tapestry of life we see today. Eventually, some life forms made the leap from water to land. Plants colonized the continents, followed by insects, amphibians, and reptiles. The development of new adaptations allowed life to thrive in a wide range of environments, from deserts to forests to mountains. Throughout Earth's history, life has faced many challenges. Mass extinctions caused by volcanic eruptions, asteroid impacts, and climate change have wiped out large numbers of species. But each extinction event also created opportunities for new life to evolve and fill empty niches. One of the most famous chapters in Earth's history is the Age of Dinosaurs. For over 150 million years, these incredible creatures dominated the land, sea, and air. Their reign ended with a massive asteroid impact, which triggered another mass extinction and cleared the way for mammals to rise. After the dinosaurs disappeared, mammals began to diversify and fill new ecological roles. Over millions of years, they evolved into a wide variety of forms, from tiny shrews to giant whales. Eventually, one group of mammals would give rise to primates, and much later to humans. The story of Earth's birth leads at last to the emergence of humans. Our ancestors evolved in Africa, learning to walk upright, use tools, and communicate. Over time, humans spread across the globe, shaping the environment and building civilizations. We are the latest chapter in a story that began billions of years ago. Even today, Earth's surface is constantly changing. Plate tectonics continue to move continents, create mountains, and trigger earthquakes. Volcanic eruptions build new land, while erosion and weathering wear it away. The planet is alive with motion, always evolving. Water is essential to life on Earth, and the water cycle keeps it moving. Oceans, rivers, and lakes evaporate water into the atmosphere, where it forms clouds and falls as rain. This cycle shapes the landscape, nourishes life, and helps regulate the planet's climate. Deep inside Earth, molten iron moves and creates a magnetic field. This invisible shield protects the planet from harmful solar radiation and helps guide compasses. Without it, life on Earth would be much more difficult. Earth's atmosphere is a delicate balance of gases, mainly nitrogen and oxygen. It protects us from harmful radiation, keeps temperatures stable, and allows life to thrive. Human activity is now changing the atmosphere, raising new challenges for the future. Earth is just one planet in the vast expanse of the universe. Our solar system orbits the center of the Milky Way galaxy, which contains hundreds of billions of stars. The universe is full of wonders, and Earth is our unique home within it. Scientists continue to search for life beyond Earth. By studying other planets and moons, we hope to learn more about how life began and whether we are alone in the universe. Each discovery brings us closer to understanding our place in the cosmos. Earth's environment is a delicate balance of systems. Air, water, land, and life all interact in complex ways. Human activity is now affecting this balance, causing climate change, pollution, and loss of biodiversity. protecting our planet is more important than ever. Plate tectonics is the engine that drives Earth's surface changes. The movement of plates creates mountains, earthquakes, and volcanoes. It also recycles materials, helping to maintain the planet's habitability over billions of years. Life on Earth is shaped by cycles: birth, growth, death, and renewal. From the smallest bacteria to the largest animals, all living things are part of these cycles. They help keep the planet's ecosystems healthy and resilient. Earth is unique in many ways. It has liquid water, a protective atmosphere, and a stable climate, all essential for life. Its dynamic geology and rich diversity of life make it unlike any other planet we know. As we look to the future, the story of Earth's birth reminds us of our responsibility to protect our planet. The choices we make today will shape the world for generations to come. By understanding Earth's history, we can build a better future. Remember, everything on Earth, including ourselves, was forged in the hearts of ancient stars. The atoms in our bodies, the rocks beneath our feet, and the air we breathe all have cosmic origins. We are, quite literally, made of stardust. Earth is not just a rock in space, it's a living planet. Its surface, atmosphere, and life forms are all interconnected, creating a dynamic and ever-changing world. This complexity is what makes Earth so special. As we gaze up at the night sky, it's humbling to remember that our planet is just one small part of a vast universe. Yet for us, Earth is everything: a home, a cradle for life, and a source of endless wonder. The story of Earth's birth is not over. Our planet continues to change, shaped by natural forces and human actions. Each day adds a new page to the story, a story that began with a cloud of dust and continues with us. From the chaos of the early universe to the vibrant world we know today, Earth's journey has been nothing short of miraculous. Understanding how our planet was born helps us appreciate its beauty and fragility. Let's cherish and protect our blue planet, for it is our only home in the vast cosmos.